Okay, so quick review problem. Go ahead and try the quick review problem up at the top to multiply, please. Okay, try the quick review problem to multiply up at the top. Go ahead. Okay, so did you all get 3x squared plus 4x minus 15? I hope?
Yep. Yeah.
Okay, so we know, everybody with me please. So we know how to go from 4 terms back to factoring it into 2 binomials, right? That was what we learned last time. That was factoring by grouping, okay? What we need to know is how to go from 3 terms to 4 terms. We need to know how to break that middle one apart. So we need to know how to undo the combining like terms, right? Because that's how we go from 4 terms to 3 terms, is we combine like terms. So going backwards, we need to know how to undo combining like terms, okay? And know which one specifically to use. All right, so here we go. So remember, factoring is like undoing distribution. Okay, this is called the AC method, okay? And this is why. Every standard, or the standard form of a quadratic, and I don't really care that you know this, but for our sake, every quadratic in standard form is of the type ax squared plus bx plus c. Sorry, my marker's all messed up. Ax squared plus bx plus c. Okay? Every quadratic in standard form is of this type. So this is called the AC method. Do you see a and c in this equation? Huh? On mine on the board. Yeah, right? You take the first term and multiply it by the last term. That's why it's called the AC method. Okay? So let's do that. So let me pull my paper back over here. So step 1 is multiply the A and C. Okay? So A and C. So I'm going to have to go back and forth because I won't have room to do this if I don't zoom in a little bit. Okay, so over here on the side, we're going to do AC. So AC equals 3x squared times negative 15, right? That's A and C. 3x squared times negative 15. So what is 3 times negative 15? Don't hurt yourselves. Negative 45, good. So negative 45x squared. So now, this is when warm-up comes into play, okay? Because let me scroll back over here to my steps. Step 2 is what multiplies to this new number and adds to the b value, or the middle value, okay? So I want to know, everybody got that down? Can I scroll back over to my problem? Sorry, I'm going back and forth. So I want to know what multiplies to negative 45x squared, that's my AC, and adds to 4x. So this is exactly what we did on warm-up. So I need to list factors of negative 45x squared. So I have negative 1x and 45x. I have 1x and negative 45x. Neither one of those adds to 4. So let's keep going. 2 doesn't work. So I have negative 3x and 15x. I have 3x and negative 15x. Do either one of those add to 4? Nope, got to keep going. Okay. 4 doesn't work. Let's do 5. So I have negative 5x and 9x. 5x and negative 9x. Do either one of those add to 4? Yes. Which pair? Negative 5x and 9x, or 5x and negative 9x? We want a positive 4 in the middle, right? So look back, I want a positive 4x in the middle. So the pair that I want is negative 5x and 9x. Once you find that pair, all of this becomes very, very easy. Okay? So once you find that pair, now all I'm doing, let me scroll back over here to my steps. Rewrite the given trinomial, so the given problem, break the middle term into the two found factors from step 2. Okay, so all I'm doing is taking the middle term and I'm breaking it apart. Remember, that was our goal. That was the only thing we needed to learn today. We already know what to do once we have 4 terms. We need to know how to break the middle one apart, okay? So first term stays, 3x squared. Middle term breaks apart. So 4x becomes what? What were the 2 terms that we just found? Negative 5x and positive 9x. So minus 5x plus 9x. So all I did was broke the middle term apart. And notice, if you combine like terms back together, negative 5x plus 9x is 4x. So I didn't really change my equation. I didn't change anything about my equation. I just broke the middle term apart. And then minus 15 stays. Everybody follow me? First term stays the same. Last term stays the same. I break the middle term into the 2 parts that I have. Now what do you see on your screen? This should make you happy. 4 terms, which you know what to do with, right?
On our screen.
On your paper, my screen, whatever. Yeah. Okay, so step 4, now that we have 4 terms, what do we do with 4 terms? Come on, what do you do with 4 terms? Factor by grouping, right? So factor by grouping. Okay, so factoring by grouping. So I take the first 2, find the GCF. So what's the GCF of 3x squared and 5x? Just x. And then I have 3x minus 5 inside the parentheses. Out of the last set, 9x and 15, it looks like I can divide out of 3. So plus 3, since it's a positive. 9x divided by 3 is 3x. Negative 15 divided by 3 is minus 5. My parentheses are the same. So I bring the 3x minus 5 out. And then I'm left with x plus 3. So the last half, you already know what to do. That's factor by grouping, right? GCF, GCF, GCF. That's all factor by grouping is. And the warm-up stuff is exactly how you do the first step, breaking the middle term apart. Multiply A times C. Find the numbers that multiply to that add to the middle. And then once you break it apart, you're factoring by grouping, which you already know how to do. Okay? This is crucial because it works for every single trinomial that is factorable. Okay? If you can factor it, this always works. There are some that we will come upon that aren't able to be factored, and we'll figure out other methods for those next unit. Okay, but for now, everything that is factorable, you can factor by AC method. That's why this is so essential. Okay? Any questions before we move on to another example together? Okay, let's look at example 2. Okay? So first thing I need to do is multiply A times C. So AC is going to be 3. Can we make them x's? Let's make them x's. Okay? So I have 3x squared plus 3. So not plus 3, sorry. Times 3. So 3x squared times 3. So what is 3x squared times 3? 9x squared, right? So I'm finding the factors of 9x squared. And I want the factors of 9x squared to add to negative 10x. So remember, when we're finding the factors of a positive number, we want both positives and both negatives. So I have 1x and 9x. I have negative 1x and negative 9x. Do either one of those add to negative 10? Yeah, they do, right? So I don't need to go on. Once you find the pair, you don't need to keep going. And to be totally honest, once you get good at this, you might not even have to list your factors, okay? All the way up until the test, you might have to list your factors, okay? Which is fine, but some of your peers around you might not have to list factors, or some of you guys might not have to list factors. That's okay. Okay, if you get good enough at these that you can just think about it and figure out the factors, that's fine. Okay, but if you're struggling to find the factors, you can always list them, okay? So once I find negative 1x and negative 9x, what do I do with those terms? Look back up to your steps. Once I find those factors, what do I do next? Break the middle apart, right? So I break the middle into those two things. So 3v squared and 3 are going to stay. And negative 10v becomes these two things. Minus 1, sorry, we're doing x's, right? Sorry. And minus 9x. So I have 3x squared minus 1x minus 9x plus 3. So all I did was change the middle term, broke it into my two factors. Now that I have 4 terms, you guys finish the problem. Okay? You guys finish the problem. This is not the right answer. Can you erase this? No. Don't erase that. Just the bottom. Did you see what I did to get the parentheses part? Okay. So how I get this is I group the first two together and take out the GCF. So what's the GCF of 3x squared and 5x? X. So I bring x out in front of the parentheses, and then the stuff inside the parentheses is after I divide the x out of it. So you divide the GCF out and put it out in front of the parentheses. So 3x squared divided by x is 3x. Negative 5x divided by x is negative 5. And then I group my second two together. So what could I divide out of at 9 and then negative 9x and negative 15? 3. So 3 comes out in front of the parentheses. 9x divided by 3 is 3x. Negative 15 divided by 3 is negative 5. So we bring out a positive 3 and use a plus sign here. Can you go ahead and put the parentheses back around here first? Yeah, okay. So now what do these two terms have in common?
Oh, it is minus 3. I was looking at the one on top. I'm sorry.
So
minus
here's
three.
one term. Here's
I was looking at the first example. Because it's v x plus.
So they both have the parentheses in common, right? So I'm going to do one more GCF. I'm going to bring 3x minus 5 out front. So right now, and then if I take 3x minus 5 out of this, what am I left with? X plus 3 is your second set. That's grouping. That's factoring. Taking 4 terms, GCF of the first two, GCF of the second two. That's factoring. Okay, so try to do Yeah, I just need to keep going because we already found the only reason I would keep listing is if I didn't find it. Okay? If I was adding to like negative 6x, then I have to keep going. Oh no. Okay, so with my 4 terms, I group. So out of the first two, I can bring out an x, and I'm left with 3x minus 1. Remember, if I have a negative 9, if I have that negative in the middle, I want to bring it out. And out of 9 and 3, I can bring out a 3. So negative 9x divided by negative 3 is 3x, positive. And 3 divided by negative 3 is a minus 1. So then my parentheses are the same. So I bring out the 3x minus 1. And I'm left with x minus 3. Okay? Okay. So I want you to try A and B. Only try these A and B. Don't go on to C and D because I need to prep you on those first, okay? So try A and B. Go ahead. Okay, here's number A. Number A. Wow. Here's letter A. Okay, you may not have had to list out all of the factors of 60n squared. Okay, you may have just been able to think, oh, it's 4 and 15. That's okay. Okay, but however you find it, you find 4n and 15n. And that's what my middle term breaks into, right? 19n becomes 4n plus 15n. And then once I have 4 terms, I'm just factoring by grouping. Out of the first 2, I bring out a 4n. Out of the last 2, I bring out a 3. My 5n plus 1 parentheses are the same, so I bring those out. And I'm left with 4n plus 3. So 5n plus 1, 4n plus 3. Okay. All right, so I'm going to keep recording on my iPad, but I'm going to write, we're going to start our factoring cheat sheet on the board. Okay? So factoring cheat sheet. What is the easiest and first method of factoring that you learned? What'd you say, Liam? Just the GCF, right? That's the first thing I should always check because it's always going to make my problem easier if I can take out a GCF first. So starting off my factoring cheat sheet, I'm always going to try GCF. Okay? Always. Every single problem that you come to, try to find a GCF. Okay? Secondly, I'll write the if over here. Secondly, I'm going to try grouping. When do I use grouping?
When there's
4 terms, right? So 4 terms only. If there are not 4 terms, if there are only 3 terms, I have to take one more step back. And if there are 3 terms, what do I try?
AC.
The AC method, right? So if there are 3 terms, then I try the AC method. Okay? So always try a GCF. Always, always, always try a GCF. It'll make your problem easier. After you do a GCF, check, are there 4 terms? If yes, then group. If there are 3 terms, then you move on to the AC method, okay? All right, so let's look at C together, okay? So on C, what should I try based on my factoring cheat sheet? A GCF. Is there any number you can divide out of 20x squared, 80x, and 35? Definitely a 5, right? Because they're all ending in a 5 or a 0. So let's try that first. So GCF, if I factor out a 5, no, let me not do black. If I factor out a 5, I'm left with 4x squared. 80 divided by 5, is that 16? I think, yes, it is. So plus 16x, and then 35 divided by 5 is plus 7. Is there anything else I can take out of 4, 16, and 7? No. So why did this help us? Did you guys really want to find the factors of whatever 20 times 35 is? Yeah, I don't either. Okay, that's why a GCF can be helpful. I don't want to multiply 20 times 35 and then find the GCF, okay? And then find the factors of that. I don't want to do that. So instead, I take out my GCF of 5, and now what do you have inside the parentheses? How many terms inside the parentheses? 3 terms. So now I do AC method, okay? So now I'm doing the AC with my new A and C, right? 5 is not part of the AC method anymore. It just stays outside. So my A is 4x squared. And my C is 7. So 4x squared times 7, that's 28x squared. So I'm finding the factors of 28x squared, and I want the factors that add to 16. So I start with 1x, 28x. I also have negative 1x and negative 28x. Neither one of those add to 16. I have 2x and 14x. Winner, winner, chicken dinner. Okay, 2x and 16x, or excuse me, 2x and 14x. Those add to 16x. So, keep your GCF out here. And now, break your middle term apart with the factors you just found. Yes, ma'am. All right, so, sorry. So now I break these 3 terms into 4 terms, right? By breaking the middle term apart. So 4x squared stays the same. 16x now becomes plus 2x plus 14x. And then plus 7 stays the same. So now I've broken 3 terms into 4 terms. All I do is group on the inside, right? 5 just keeps coming down. It never changes. It's just going to stay there. So now I group with the 4 terms that are inside. So out of 4x squared and 2x, I can bring out a 2 and an x. 4x squared divided by 2x is 2x. 2x divided by 2x is plus 1. Then I group with my last 2 terms. Out of 14 and 7, it looks like I can bring out a 7. So plus 7. 14x divided by 7 is 2x. 7 divided by 7 is plus 1. My parentheses match. So 2x plus 1 comes out front. And 2x plus 7 is left over. Is that problem done and complete? Not quite. 5 is part of it. Okay? So 5 is my third factor there. Okay, so there's actually 3 factors of this. So there's my final answer. Make sure your GCF comes all the way down to the bottom, because I want my answer and my starting problem to be equivalent. Okay? I'm not changing anything. All I'm doing is factoring it. I'm breaking it down into its smallest parts. Okay? All right, you guys try D. I'm going to leave this up on the board. You guys try D. D is actually a little more complicated. Okay? Because your GCF includes a variable. So that's my hint to you on D. Your GCF includes a variable. Okay? So try D together with your partners. All right, so I check for a GCF. My GCF is 2n. So I have 2, oh, need a pen, sorry. 2n, and if I factor out a 2n, I'm left with, ladies, please. I'm left with n squared plus 2n, no, 7n, sorry. 7n minus 60. So now I'm doing the AC inside of my parentheses, right? So AC inside of my parentheses, I'm taking AC equals n squared times negative 60. So I have negative 60 n squared. So I'm finding the factors of negative 60 n squared that add to 7. So I go 1 and 60, that doesn't work. 2 and 30, that doesn't work. 3 and 20, that doesn't work. 4 and 15, that doesn't work. Then I get to 5. So I have negative 5 n and 12 n, or 5 n and negative 12n. Which pair adds to positive 7n? Negative 5 and positive 12, right? So this is the pair that I'm picking. So remember, GCF stays out front. Inside, I'm just going to break 3 terms into 4 terms. So the first one stays. 7n breaks into plus 5n minus 12n. And then negative 60 stays the same. Now that I have 4 terms inside the parentheses, I'm going to group. So out of n squared and 5n, I bring out an n, and I'm left with n plus 5. Out of negative 12n and negative 60, I'm going to bring out a negative 12, and I'm left with n plus 5. So n plus 5 is in common, so it comes out front, and n minus 12 is left over. Don't forget to bring down your GCF. So my final answer is 2n, parentheses n plus 5, parentheses n minus 12. Okay? What is the point of this? Anybody thinking that in their brain? Mr. Craw, why are you teaching us how to factor? Okay? The big reason is because it makes solving a lot easier. Okay? It makes solving a lot easier. So let's look at the back page. Okay, so example 3. Can you solve that example? Everybody put your pencils down. Everybody put your pencils down. How would you tell me how to get rid of an x squared? What's the opposite of squaring? The square root. So okay, let's square root every piece. Don't write this down. So if I take square root, square root, square root, now I have square root of 5, square root of x squared is x, so I have x squared of 5, plus square root of 16 is 4, but the x is still left in the square root, and square root of 12 is, just take my word for it, 2 square root of 3 if I simplify, equals 0. Does that look easier? No, not at all, right? So We do not know how to solve stuff with x's and x squareds. Well, we do now. Can you solve? So over here on the, I'm going to do a little side work up here, okay? So I'm going to tell you up at the top, I'm going to tell you that x squared plus 5x plus 6 equals is the same as, if I factor it, x plus 2 and x plus 3. Okay, write that up at the top of your paper. Very tip top. X squared plus 5x plus 6, when you factor it, is x plus 2 times x plus 3. Okay? Which if you did the AC method, you could figure that out. Okay, but I'm going to skip that for now. Can you solve x squared plus 5x plus 6 equals 0? We don't know how to do that. So what if I factored x squared plus 5x plus 6 and I made it x plus 2 times x plus 3 equals 0? Does that make it any easier? It should. If I am multiplying stuff together and I want my answer to be 0, what does it take to make my answer 0? Like if I had x times y equals 0, that would mean either x is 0 or y is 0, right? If I'm multiplying and just one piece is 0, it makes the entire thing 0. So I have two answers for this. I have one answer that x plus 2 could be 0, and I have another answer that x plus 3 could be 0. So if I break it down into simple parts with multiplication, I can now say either this piece is 0 or this piece is 0. That's why factoring makes things simpler. Okay? Because it's hard to solve x squared plus 5x plus 6 equals 0. That's hard to solve. But x plus 2 equals 0, I can solve that easily and say x equals negative 2. X plus 3 is easy to solve. I can say x equals negative 3. There are my two answers. So factoring makes solving a lot easier. Factoring is just one method that we have to help us solve. So that's the long-winded answer of why we are doing what we're doing. So now let's look at actually solving, okay? All right, so can I move this up? I'll give you a second to finish copying that. Okay. All right, so let's look at example 3. So I don't know how to solve this because it's got x squareds in it. Okay? That makes it a lot more difficult to solve. So I'm going to break it down into easier parts. Breaking something down into easier parts is simply factoring. Okay? So on example 3, can we find a GCF? Can you find a GCF? No, there's nothing that divides into 5, 16, and 12. So I tried that. There are 3 terms, so now I'm going to group. Okay, so I'm going to use, there are 3 terms, so now I'm going to do the AC method. So AC over here is 5x squared times 12. 5 times 12 is 60x squared. So I'm trying to find the factors of 60x squared that add to 16. Can you think of 2 numbers that multiply to 60 that add to 16? 10 and 6. Okay, so we're going to use 6x and 10x. If you need to list out factors, that's fine. We're going to use 6x and 10x. So now I break 3 terms into 4 terms. So I have 5x squared. 16x is going to break into plus 6x plus 10x. I still have my plus 12, and it still all equals 0. Okay? So now that I have 4 terms, I group. So out of the first 2, I can bring out an x, and I'm left with 5x plus 6. What can I divide out of 10x and 12? Just a 2, right? So plus 2. 10x divided by 2 is 5x. 12 divided by 2 is plus 6. Still equals 0. Don't forget that equals 0 part. That gives us purpose to what we're doing. My parentheses are the same. So 5x plus 6 comes out front. And x plus 2 is left over. Now I have just made solving a lot easier. Okay? Because in order for this whole thing to be 0, either this piece could be 0 or this piece could be 0. Everybody look up the screen really quick. I'll say it again. In order for this whole thing to be 0, either this piece needs to be 0 or this piece needs to be 0. So I set up two equations. I'll do them in different colors. So I'll set up this one in red. 5x plus 6 equals 0. Or this piece, x plus 2 could be 0. So I'm going to get two answers. So solve both of these equations separately. So minus 6 minus 6. 5x equals negative 6. Divide by 5, divide by 5. And I get x equals negative 6/5. That's one answer. The blue one's a little bit easier. Minus 2 minus 2. X equals negative 2. There's my other answer. The only time you are required to solve is when there is an equal 0 at the end. Okay? The only time you're required to solve is if there's an equal 0 at the end. I am going to skip the try these problems because I want to give you time to work on your homework, okay?